So my name is Jelle. I'm an independent JUCE contractor. I work on my own company, JB Audio. I work on plugin and desktop apps. And my role in most projects is software architect. So I'm mostly busy with, improving software design and structure. Besides that, I'm a cellist, producer. I like good coffee, and 11 months ago became a father. So what's this talk about? So we're going to explore state management in the context of JUCE software, especially plugins, and we're going to learn about challenges and how we can solve them with JUCE. I'm trying to make this talk useful for both beginners but also intermediate developers. So, quick overview. I'm going to first discuss what is state to give this talk some context, discuss the challenges that come with state. I'll propose MVC as a general approach for state management. I'll then give a quick introduction to ValueTree. It's probably the most important object you want to know when working with JUCE. I'll talk about parameters when you have plugins, and more on ValueTree. I'll talk about user preferences and finish with a quick note on threading. So what is state? So when you think about state, what might come to mind? Well, maybe indeed the ValueTree. Maybe you've used it before, or maybe it's new to you. Maybe you think about like serialization, which is, we have to do that. Maybe you think about preset management, user preferences. So there are many things that could come to mind when I think about state management. So, but before we really dive into all these individual things, we first have to define what state really is. So I asked ChatGPT what he thought that state was. So he gave me a really nice answer. So he said that it's the condition or configuration of a program, system, or object at a given moment in time, representing the set of data or values that describe how a particular component or system is currently behaving, or the information it stores at a particular instant. So it's correct, but it's really abstract in my opinion. So that's kind of how I feel when I hear this. So in other words, you could describe it just as a sort of snapshot. So when you use any app or software, just take a sort of virtual snapshot of your app at any moment, and you get your state. So it's all your sliders and buttons, but also things in the background, like your parameters, but also things like your audio, like delay lines that store internal audio. It's all kind of part of state. So what kind of challenges do we have with state? So the first challenge is that state is really everywhere. So we have a lot of different forms of state. First one is, for instance, a plugin state. So think about you're running plugin in Logic, and Logic wants to get your state to save it in a project. So it asks for state, and that's your plugin state. So it contains all the settings for your plugin. There's also potentially UI state. This could be part of plugin state, could also be completely separate. If you're not having a plugin but a different kind of app, you might just have a UI state. Maybe you don't have audio at all, just have a UI. There could be a global state, like preferences. It's a state that's shared between multiple instances. If you run a plugin, you might have preferences you want to share between the plugins. So there's many more forms of state, like momentary state. That's what I define as things like level meters, things that continuously change, that are defined in the moment. A shared memory state, for instance, we have some singleton thing that's shared between the different plugins. You want to maybe communicate between plugins, some kind of state. So many forms of state. Your host has a state. You have undo redo state. You have media state, preset state, server state, and well, it's everywhere really. So this is first challenge because you want to have some kind of interaction and synchronization between all these things potentially. Another challenge is interactivity. So let's say we have a volume knob, and you turn it. Many things could happen, right? So well, of course you need to update your volume if you have a volume knob, but also you might need to inform your host about the change, including you need to send gesture changes. So when you start dragging the knob and when you finish dragging the knob, you need to send like notifications for those events. Maybe you need to update your plugin state. Maybe you have a UI display showing the latest value you changed. You need to update that. You need to update undo manager. Maybe you need to send MIDI or send a OC message or write to a log. Anyway, so there's a lot of interactivity in many software. If you don't carefully manage state, you end up with a lot of spaghetti code. So where all parts of code know about each other. You have a lot of couplement and it's not maintainable at all. Another challenge is saving state. So we need to make states serializable. For instance, what I just said about plugins, you need to give your host, your Logic or Pro Tools, whatever, you need to give it your state in some format. This could be a human-readable format if you want it as a developer to read it or for your users to read it. But it could also be a binary format, right? If you want to optimize for memory, for performance, you might want to store state as a binary format. You also need to think about backward and forward compatibility when saving state, so that if you update your plugin to a newer version and you load a session of Logic with your old plugin that has state of an old plugin version, you need to think about it. It's all compatible and it's both backward but also forward. So you might want to version your state. There's also this challenge of when you load the state, you need to kind of build up your app at runtime. So if you have a big DAW project with a lot of tracks and clips, they all need to be built up when you load your state. So there's a lot of sort of state setup there. Maybe security as well. I will not cover that this talk, but some people are concerned with protecting your state from hackers. So yeah, my point is state is really involved. You have a lot of things, maybe automation, state interface and structure. As a developer, you need to code and you need to work with state. So yeah, state setup, as I said, maybe threading, scalability, testability. Potentially, you have some resources that the state depends on. Maybe it refers to some audio files on disk. So yeah, many things. So yeah, I'd like to propose MVC as a sort of way to think about state and solve one of the challenges on a large scale. So MVC is stands for Model View Controller. So you try to divide your software into 3 parts in general. So the first one is your model. That's just all your data, right? So it's all the values of your state. It's just the data. The view is also, I think, very clear. It's just what you see as a user. It could also be things like that you hear. So it doesn't have to be literally a view, but it's a sort of representation of your model. And then there's the third part. It's the controller that takes care of like the flow and the management of manipulating, but also observing your model. So there's these 3 things, and I want to point out also that there's a lot of discussion about the exact definition of these 3 and how they interact. And I'm not trying to give answers to that. I'm just trying to suggest a way to think about your software and try to divide these parts roughly. And it doesn't have to be exactly like this. You also don't have to exactly name your classes like this. It's just in general a good approach to separate your software. So if we have these 2 parts and we have a user, where will the user in general be? It's probably going to be the view. It's going to be you because you see stuff or you hear stuff, that's you. So yeah, your UI is going to be there. Maybe also your audio because it's a representation of your model. And then now it's going to get a little bit more complicated because let's say we have ValueTree. So it's I'm going to share about ValueTree in a moment, but it's like a data structure in JUCE. So it's going to be your model, obviously, but could also be considered a controller because you can also observe ValueTree and manipulate ValueTree. And with parameters, it's kind of the same thing. They contain your state, but they also allow observation and manipulation. So yeah, again, there could be a lot of discussion about where things are exactly, but yeah, just a rough example. I'd like to now introduce ValueTree. It's one of the greatest classes in JUCE because it just allows for writing your whole app around a state. Well, ValueTree is your state management object. First, I want to point out there was this talk from David Rowland at the previous ADC conference, which I highly recommend you watch because this gives a very deep dive into ValueTrees, and it's just great. I think one of the greatest talks at ADC in the past. So yeah, I highly recommend watching this talk. I'm going to try to share some of the basics of ValueTree, but also share some things that David didn't cover and some issues that I encountered myself and that I had to struggle with and solve. So I hope this is going to be useful for also people that watched this talk already. So what is ValueTree? The documentation defines it as a powerful tree structure that can be used to hold free-form data and which can handle its own undo and redo behavior. So the first thing it says it's a tree structure. So this makes it suitable for many many applications, because many software, you can sort of organize your state in a tree format. And ValueTree is designed mainly around the XML format, which means XML works with every node in an XML has a type and properties. Whereas for this JSON is a bit different. So it's not, ValueTree cannot directly be serialized to JSON, but it can to XML. It's a free-form data, so and it does that using the JUCE var. JUCE var it's similar to vars in other languages, I think like JavaScript, where it stores sort of any data, but mostly it's used for primitive types and strings. But it can also store arrays and some other things. But if you want your ValueTree, if you want to be able to serialize it to XML, you have to make sure that the vars you use do not store complex things that do not have a string representation. So yeah, you want to mostly use it for strings and numbers and stuff like that. It's undoable, which is great. So every operation you do to ValueTree, whether it's adding things to it or changing properties, you can pass an undo manager, and then ValueTree will configure the undo manager to be able to undo the change you just did. So that's great. Its reference is counted. So when you copy ValueTrees around, you're not actually copying the underlying data, you're only copying a reference to the underlying data. So it's similar to shared pointer. So you can easily copy it around and they all will share the ownership of the ValueTree. This makes it easy to observe, because when you observe a ValueTree, you are actually adding a listener to your local copy. So when you destroy your local copy, you're not destroying the underlying data, but you're destroying your listener. So I'll show this in a second. It's very useful, but it's an important concept to understand that it's when you copy ValueTrees, you're not copying actually the underlying thing. And as I said, it's serializable as long as your JUCE vars that you use to store are all primitive types of strings. It's observable, so any change you make, you can watch it and you get callbacks when things change. There is no thread synchronization. So in general, you want to use ValueTree on one thread. Many times it's going to be the main thread, because many UI things also, UI has to be on the main thread really. So yeah, ValueTree, you probably want to mostly use it on the main thread, but there is no enforcement. You can do it on any thread, and you have to make sure that you only use it on one thread or provide your own thread synchronization outside of it. So yeah, a quick example of ValueTree. You'll first define your IDs. So every type of ValueTree and properties, they all are identified with the JUCE identifier. It's basically a string, but it's a bit more optimized string that can easily be compared. So it's a more optimized string basically. And then you can create your undo manager. And this is an example how to create a track and assign a property again to the track. And you can see when we assign the game, we also pass undo manager. For clip, the same thing, and then you can add a clip to a track. And there's an example how to write a sort of gain DSP object. So let's imagine we have gain that when applied to an audio buffer, we could pass a ValueTree to the gain in a constructor, assuming the ValueTree has a gain property. And then we're going to observe the ValueTree, and when the ValueTree changes, we're going to update the atomic from the ValueTree change, and then when we apply it, it will always be up to date. And also notice that the listener we add, there's no remove listener, because we've copied ValueTree, and the listener that we assign to ValueTree will safely be deleted when the ValueTree copy is removed. All right, I'd like to now talk about parameters. This is mostly useful when you create plugins. But also when you have audio processor, JUCE objects, maybe you don't have a plugin, but you could still have parameters. So this is the class you're going to use, the audio processor parameter. It's, according to the JUCE documentation, an abstract base class for parameter objects that can be added to an audio processor. And then on the left side, you can see the most simplified picture of how this then works. If you have a DAW and your plugin, they will both need to manipulate and also know about your parameter. So your changes could come from automation, but also could come from user dragging a slider in the plugin. And well, the structure of inheritance is quite complicated. It's kind of how it evolved over the years, but it's only the part around the rectangle that you're really going to be worried about, because you want to create concrete parameters. And this base class is only really an interface for it. I also want to point out between the DAW and your parameter, from your JUCE perspective, there's of course going to be like plugin formats. So JUCE encapsulates the plugin formats, all the parameter differences in this one class. So with JUCE, you generally don't really do any specific VST or AU things. Explicit, it's all encapsulated in this class. So yeah, it's useful for automation. You need to think about gesture changes. So I already said this, but your host wants to know when you start and finish dragging sliders, so it can like draw a nice line for automation when you want to write that. So when changing a slider from your plugin GUI, you have to send first and begin gesture change, then your change, and then when you release with the mouse, you need to send end change message. The state is stored as a normalized 0 to 1 float. So if you have like a 3-choice parameter, this is going to be mapped to 0, 0.5, and 1. If you have a 4-choice, it's also going to be met within this range. So it's good to know this, especially when you in the future want to add new choices to your parameter. It's good to upfront reserve choices, because your automation in your DAW will still assume that you have a 3-choice, but if you have a 4-choice, this mapping is going to be corrupt. So you could upfront reserve a few choices that you don't use yet, but this will make sure that automation from all projects still work with newer versions from your plugin. You can convert this normalized 0 to 1 easily to a useful range with the range parameter convert from 0 to 1 function. One thing I also want to point out is the state could be changed from any thread. In practice, this is very likely going to be either your audio thread or your main thread. And I think this is also specified in some plugin formats that it has to be main thread or audio thread, but well, hosts do all kind of things. So it's good to assume it could be any thread. So when, for instance, your DAW sends automation changes on audio thread, you want to update your UI slider, that has to happen on the main thread. So there has to be some kind of thread synchronization to avoid well, thread issues. You can safely use the value from a parameter on the audio thread because it will be stored in an atomic in the concrete implementations of the parameters. So you have these parameter float, parameter choice, bool, and int, and they will internally store an atomic. So you can safely use those values on the audio thread. There are a few problems if you just use this class as it is. Well, first of all, there's no synchronization to any centralized model. So if you have all these parameters and you want to save them as an XML, JSON, or something, there's no state already for you that you can serialize. You have to yourself iterate through them and then store them in a state. So that's the first problem. Second problem is, as I said, these callbacks where you get changes of the parameter. It can happen on any thread. So this can make it hard to implement your UI. Also, these callbacks that you get, they get normalized values. So you first have to convert them to your actual range. So if you have a parameter from 0 to 100, you have to convert it 0 to 1 to 0 to 100. And there's no undo redo. So the first object that's solving some of these problems is the AudioProcessorValueTreeState. I'll call it APVTS from now. This will store your parameter state in a value tree. So it's going to be XML and will kind of look like this. So every parameter is going to be a node in your state, and it will take care of your state. And the documentation says the class contains a value tree that's used to manage an audio processor entire state. And when you hear entire state, it's going to be your parameters and any state that you yourself define. So because maybe you have some things that you don't necessarily want to be parameter, maybe like paths to an audio file that you need to store, or preset name, things like that. So yeah, it provides easy serialization because this value tree will always be up to date with your parameter changes. So at any point where you need to know your state, you can just get it and serialize it. It also takes care of parameter management, so you can easily add parameters to your APVTS and it will manage them and will also make sure that your plugin processor will know about them. It takes care of undo redo. It also provides an unnormalized parameter value as an atomic float, which you can use in your DSP. This is a slightly optimized way of accessing your parameter float, because as I just said, you can also access your value through the atomics in the parameters. But if you do it that way, there's going to be always a conversion from normalized to unnormalized. This one is always going to be unnormalized, so it's a slight optimization. And well, the most important thing really is that all your parameters will always be synchronized to this value tree. So at any point in your application, you have access to a up-to-date value tree state. Not sure what that is, but I'll go on. Okay, so this is a quick diagram of simplified version of like your plugin flow, sort of. So on the left side, you have your UI, so you have some kind of slider. Then the user changes the slider. It will update your parameter. So as I said, the slider has to update the parameter and cannot go directly to the value tree because it has to inform your host and also send the gesture changes. So it will go to your parameter and then your host will know about it. And then your APVTS is watching your parameter and will then safely, with some thread synchronization, will update your value tree on the main thread, even though your parameter could have been changed on the audio thread. In this case, it's going to be from the main thread, but your DRW could update it from the audio thread. So your APVTS takes care of the thread synchronization. It will update your value tree, and then at any point, you can convert it to XML when your host wants to get your state. Quick example how to use APVTS. Part of this is grabbed from JUCE tutorials. So you create your APVTS, where you can pass in a list of parameters. You can then use it in your DSP code to apply it. And it's going to be an atomic. You probably want to store this, get parameter value as an atomic somewhere, so you don't get it every time. But for the sake of example, I keep it simple. You can use the slider attachment from JUCE to easily attach parameters to UI things. So this is all the code you need if you want to have a slider fully configured with the right range and default values and everything, because the slider attachment under the hood will take care of all of that. And of course, the serialization. So it's just these two lines you can use to fully serialize and deserialize your APVTS state. Second class you probably want to use if you have components in your UI that are not necessarily covered by these slider attachment. And there's a few default attachment classes from JUCE, but if you have a component, something like maybe an XY pad or ADSR or something, it's not covered by JUCE, so you can easily write your own attachment using the parameter attachment. So you pass in your parameter and you pass in a callback that you will get on the main thread. So this can be very useful when you want to update a UI parameter on the main thread when the parameter, when you want to update the UI's component on the main thread when the parameter changes. You also can pass an undo manager when you want to, the other way around, when you want to update your parameter from a UI component. So yeah, the callback is going to be on the main thread. It takes care of gesture changes. There are two options. You can do a gesture change as a complete gesture, which means it's when you want to change a value and right before, right after, want to send a begin and end gesture change. It's useful when you have things like buttons, where there's no obvious start, drag, and finish drag button. You just click it. And there's part of a gesture where you have things like sliders, where you have a clear begin and end of dragging. And it takes care of undo. So with the slider, for instance, when you begin with dragging, your parameter attachment will send an undo transaction in undo manager. So when you drag for like 10 seconds and then release it and you click undo, it will go back to the value before you start dragging, instead of every step you dragged would otherwise be an undo transaction. That's useful. Oh yeah, it can be used without APVTS. If you don't like APVTS or it's a too big step to transition to using it, you could already start using these classes to make your connection between your parameters and your UI very neat. So yeah, quick example. I have some imaginary ADSR components that I want to attach to a parameter. So the example is you want to just attach the attack parameter. So you create your parameter attachment, you pass in your attack parameter, and then there's going to be a lambda that's going to be executed when the value changes, either from your DAW or from maybe from a state update or something. So we'll update the UI when a tag changes. And then the other way around, when you start dragging the component in your plugin UI, when you start dragging, send the begin gesture. When you finish dragging, send the end gesture. And when during dragging, you send the set value as part of gesture. And then you finish this code with, you have to, when you construct the parameter attachment, you have to call send initial update to force your component when it appears to be in the right state. Okay, many people ask about how do I have non-automatable parameters? Well, there is this isAutomatable function in the parameter base class that you could use, but it's only a hint. So it's up to your host whether to respect this or not. And there are many hosts that do not respect this and make your parameter be automatable anyway. So the best approach is to just not make it a parameter at all and store your state directly in the value tree, because your host will not know about the value tree at all. It's just internal, and then there's no automation. You can easily attach still GUI objects to your value tree using the value, but I'll come to that in a second. And then you can also easily attach DSP to value tree using atomic wrapper, part of Traction. Traction is another library extension of JUCE, which has it's mostly used for DAW projects, but there's a lot of nice state management stuff in it as well. But one little trick that I found out recently is you can actually create another APVTS and assign it to a dummy processor, and this will allow you to still use parameters that your DAW doesn't know about, because it's only part of your dummy processor. So, but if you have two APVTSs that share, if you have two APVTS that share the same value tree, then you can use this approach to have parameters that do not show up as automation in your host. So a bit more on value tree. So there are many things you can misuse value tree, because it's very dynamic. It's, as I said, free-form data, so you can do anything with it. So this is a problem if you have a large application where you access it from many places, because you can, pass the wrong type or the wrong. You can accidentally manipulate the wrong property or the wrong tree, or forget to pass in your undo manager, or well, it's very easy to mess it up. So one solution for this is using cached value, because cached value is basically a wrapper class around the property in a value tree, where you get compile time problems if you misuse it. So let's say we have a name, maybe you have a track value tree somewhere, and there's a name in it. There's a string that you can construct it like this, and it will allow you to access name without all the dynamic code. So value tree defines it as this class acts as a typed wrapper around the property inside the value tree. So it wraps the value tree for a chosen type. Internally, it's a value tree listener, because it will internally watch the property and keep a copy of it as a string. So it's good to know this, especially when you're also a value tree listener and when you use this cached value. It can happen that your cached value that you're using could not be up to date yet, because you want to use the value tree. You want to use the name cached value in a value tree listener callback, but the name is also updating it in the same sort of callback, and it could happen later. So this is a problem that you can solve by calling force update of cached value. So if you want to use name in a callback of the name change, to be safe, you have to first call the update of cached value to make sure the value is actually up to date. There are a few alternatives. That is, you could write your own non-cached value that is still doing the type wrapping, but it's not caching it. And I've done this myself for free projects because I didn't really need the performance benefit of the caching. I just wanted to have the easy conversion and the compile time checking of types. This can be a useful approach. Or what you could do is you could handle callbacks asynchronously. So when the name changes, you could say, well, okay, I'll just do an async callback, and sometime later I'll handle the name change when I'm sure the cached value has got the property callback and has updated the string. There is this class in Traction called flagged async updater, which allows you to very nicely, if you have a complicated class where there are many property changes that you want to each handle individually async, it's very nice, so look it up. For cached value, you could be using it also for non-serializable types. So imagine you have a cached value of an array or a color or something that does not have a string representation. You can use variant converter to write your own conversion to string from these types. So here's an example how to do that. Let's say we have an enum, transport state, 3 states, and you want to use it in a cached value. Then you can write this template variant converter that gives you the option to convert your var into an enum and also the other way around. So this allows your enum to be stored in your value tree as an int, but you can use it as an enum. The next thing I want to cover is tree wrappers. This is one next step for avoiding mistakes, and it is to write wrappers around value trees. So imagine you have a track that has a name, a gain, and a pen, probably more stuff, but at least this, and you want to use a track nicely in state, you can write a track wrapper. I'll show a more extensive example in a second, but first I want to point out the advantages. So first of all, you have a much simplified API. You have encapsulation because basically all the value tree stuff is just hidden. You can use cached values for accessing your properties, and you can use std functions for watching properties, and all the value tree, nice stuff that has serialization, everything, it's all hidden. It's also self-documentation. So if you want to know what is in a track, what properties are in the track, you can just look at this class and see, oh, these properties are there, and you don't have to guess it. It reduces complexity massively because all your complexity is now moved into this wrapper class, into the cached values. So there is still a sort of complexity, but it's all in one place. And it also reduces boilerplate because you don't have to do all these extra code outside of your wrappers in your GUI. It's all, when using these wrappers, your code is much more simple. And these wrappers can also be a great place to put in other stuff like helper functions to convert to different, maybe a 0 to 1 to a normalized range, or you can put in constants for ranges or put in data validation. So this can be a nice place to put in sort of metadata stuff. Here's a more extensive example how I would use it in a more real example. So yeah, so you have your cached values on the top, and they will use the tree that you define on the top and undo manager. And then next is your callbacks. So this class will watch your value tree. It will get the property change when it's changed from anywhere in your application. And instead of having all these if in different places, it's now all in this wrapper. Also note that I call Vars update of cached value before calling the callback to inverse the cached value has the internal value cached already. Oh yeah, also want to point out that it could be nice to actually create a class that has both of these in itself. So you could have a cached value that also internally has a lambda. Because the cached value already is a listener to the value tree internally, you could as well just expose a lambda when it changes. And then you also don't have the issue of that you have to call Vars update because there's just one listener. So maybe someone could write that. So yeah, how would you use a tree wrapper? Yeah, you first define your wrapper. This could be anywhere. You can have also multiple wrappers wrapping the same tree. But this could, for instance, be part of a member of your of some UI class. And then I have, let's say we have a track name label that we want to sync to the value tree. Then in a constructor, you would first, of course, make it visible. And then you have a two-way attachment. So you want your tree to be up to date when your label changes, and you want your label to update when the tree changes. So there's these two lambdas that very nicely synchronized the two. Actually, it should be track tree wrapper.unnamed changed on the bottom one. And then also notice the last part, that we want the label to be, when it appears, already have the correct value. So we immediately call that callback. And also, it's also a mistake because it should get the right argument. Anyway, you can simplify this using value. So all this code goes away if you attach a JUCE component with the value tree using JUCE value. What's JUCE value? A value is an object contains a reference to a var and can get and set its value, and listeners can be attached to be told when the value changes. So it's basically an observable var. And you can use the value refer to make one value refer to the same data as another value. So you can have your label easily refer to the value in the value tree. And then the value tree, as you get property as value, to return some property as a value. And I believe also the cached value also has a function to get the cached value as a value. So yeah, there are various JUCE components using value. Slider, label, and button are a few examples. So you can super easily just attach them to value tree. And what's also nice is when you call refer to, your label will immediately be up to date with the state. So you don't have to do an initial force update or something. So it's just this one line that attaches the two. Okay, there's one problem that I found out myself during development, and I've also seen other people have problems with it, and that is whether to pass value tree by value, so by copy, or by reference. So value tree is designed to be passed as copy. All the functions in value tree, most of them are by copy, and that's because it's a shared reference. So you don't copy the underlying tree, you just copy references to a tree. And that's nice because when you add listener, you listen to the copy, not to the original directly. So this is good so far. But then at some point, your logic will send a new state to your plugin to update state, and then you will you assign a new value tree to your APVTS state. So you have this underlying tree that was there, and then you actually want to have a new tree assigned to your state. And the problem is that your original plugin editor is still using the old value tree, and it will not be using the new value tree until you tell it to. So you might think there is this redirected callback that you could get when you reassign a new value tree to a value tree, but it's actually not being called because you're listening to the underlying original old value tree. So when you assign this new value tree in the set state, you do not get this callback. So what you have to do to solve this is you actually have to pass it as a reference and make sure you remove the listener in a destructor. So this kind of takes away the whole advantage of the copying, but you have to do this to properly manage state. In general, what you probably are going to do is have this code live on a sort of top level of your UI, and when you have a new state redirected, you will rebuild your whole UI, and you still pass copies, but there is one top class taking care of watching for redirection. So this is a problem that I encountered myself, and I hope it saves you some trouble. There are some more objects that you could look up yourself that are really useful. I want to point out a few ones. The first one, component builder, is really nice when you want to dynamically build up a UI based off a value tree. So it sounds in theory very nice. You could, in theory, build your whole DAW based on a track, clip, state, and stuff. However, in practice, it's not that easy, but it is useful for instance, when you want to have some kind of editor to edit your value tree, some kind of tree structure where you can just easily change properties for debugging, stuff like that. So it's very useful. Another one is atomic wrapper, when you have a cached value that you want to access from the audio thread. If you use atomic wrapper from Traction, it's automatically going to be cached as an atomic, so that's very useful. So I would highly recommend looking up these classes, and also especially Traction. So Traction is, for those who do not know, Traction is where value tree is designed for originally. So Traction has done a massive refactor using value tree and massively reduced the amount of code by using value tree. And that value tree is ported from Traction to JUCE. So Traction is open source. You can look it up, and it's a great example how to manage state with value tree. The next thing I want to cover is user preferences. So you could have multiple plugins referencing state that's global. Maybe it's probably going to be stored in some kind of file on disk, and it could contain things like authentication, maybe UI theme, things like that, right? That's shared between plugins. You could use property file from JUCE for this. Property file is a key value map. It's designed for these things. So it's a flat key value map, and you can set the file path using the option struct. The option struct has a few variables that you can tweak, like your application name, your company name, and it will then do a cross-platform. It will decide based on the platform that you're using what file path to use. It takes care of automatic file saving and loading. It will also prevent data erases from process with process log. It's observable. Yeah, it's observable. And then a quick example, this is my own implementation. I have this user preference struct that has two wrapper functions, setSkin, getSkin. And I initialize it with all these variables, and it will automatically decide on the right path for the preferences. So yeah, that's where I I decide on the path and I initialize it. I'm using ApplicationProperties, which is sort of a wrapper around property file. It's not very relevant for this talk, but it's just a small wrapper around it. So I have two wrappers. Unfortunately, there's no cached value similar thing yet for property file, so I just have a getter and setter. And yeah, and this is how I would use it in some UI thing. I observe the preferences, and then when the skin changes, I do a repaint to paint white when it's not dark anymore. And also, I'm referencing it using a shared resource pointer. A shared resource pointer it's like a singleton, where if you have multiple shared resource pointers, you're all pointing to the same object. So it's useful if you have multiple plugins, where if you change the skin in one of the plugins, the others will get updated. Alternative for property file is a value tree. So you could have a value tree if you have a more, maybe like a tree structure that's not flat and you have more complicated settings. Also my own implementation. I still use the property file options to decide on the file path. And then I have a value tree that I load from disk. And then when anything changes in the value tree, because I'm observing it, I'll just write it to file. It's very simplified. You probably don't want to write to file in every single change synchronously, but and then I have a wrapper again with the cached value and everything to wrap this this original struct. And then it's also using the shared resource pointer to allow multiple plugins to observe the same value tree. And the UI view actually becomes even more simple because you just have the wrapper with the lambda and you repaint when the skin changes. Quick note on threading. I actually don't myself want to talk about threading. I would just say trust what experts have built because it's a very deep topic and there have been many talks about this in the past. I would highly recommend use whatever is there. So use the JUCE objects that I proposed, but also consider other things like Fabian's library, some other like FIFO, and yeah, that's all great stuff. And also watch all these talks, and there may be more talks like this. But yeah, there's so many stuff about threading. It's relevant for state, but it's a talk for its own. So conclusion, JUCE has all you need if you want to manage state, and you might want to use a bit of traction as well. That was it for today. Any questions?